This is Josh White with JW Math Tutoring. Today's video is going to cover Digital SAT Practice Test 4 Math Section Module 2B, the harder of the two second modules. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Okay, just before I get started with Practice Test 4 Math Module 2B, the harder of the two second modules, just a couple things to keep in mind. First, this video will most likely be longer than the allotted time for this section, and that's because on some problems there are multiple ways that you can solve them. And so I like to show as many methods as possible because some are quicker than others, or some might be easier to understand or follow than others. Second, of course, if you like this video, please do give it a thumbs up. And of course, subscribe to my channel and sign up for notifications as well. So let's go ahead and get started. All right, so this is again question number 1, math, module 2B of Digital SAT Practice Test 4 from within the Bluebook app. All right, so we have 55 students in a Spanish club. 20% of them intend to enroll in a program. They just want to know what the number of that is. So in other words, they're asking, what is 20% of 55? So it's just 0.20 out of 55. Correct answer is going to be A. And I just do want to show you one little thing here. So in Desmos, you can technically just do percentages. So you could just type 20% of 55 and get the answer is 11. Okay? So however you do it, correct answer is 11, and we can move on to the next question. All right, here we have basically an interpretation of a linear function question. A machine's making boxes, total is 700 minutes. That's why you have all these equations equal to 700. 10 minutes for a large box, 5 minutes for a small. X is the number large, 5 is the number small. They want to know what the equation represents this. So all we have to notice is, okay, 10 minutes, large box. Variable for large box is X. So the 10 is going to be multiplied by the X. 5 minutes, small box is Y. 5 is going to be multiplied by Y. Correct answer is going to be letter B. We can move on to the next question. All right, here we have a graph. Basically, it's a scatter plot, and it's got a line of best fit shown. So for this, there's multiple ways you can do this. First of all, you can notice that the y-intercept is like right around here. It looks like it's halfway between 13 and 14. So the b value, I would say, we just estimate it 13.5. Let's say it's 13 point something. So we go to the answer choices. Okay, these negative b values down here for C and D, get rid of them. Now, the slope, is it positive or negative? Well, it's obviously negative because it is going downhill. So correct answer for this is going to be letter B. You don't actually have to calculate the slope or the y-intercept or figure anything out. But I will show you an alternate way you could do this in Desmos just if you wanted to be sure or double check. So what I would do is, first of all, I would pick 2 points. And this is just a general, how to do a linear regression. I would pick like points that are basically where the line is going through, integer values. So like right here, and maybe I would pick this one right here. So my first point looks like, let's see, it's going to be 3 comma 11. Second point looks like 13 comma 3. And now I just type in to do a linear regression. Okay, what is my slope? What is my y-intercept? So notice the slope is exact. The slope comes out to negative 0.8, which is what we see for our correct answer here. But the y-intercept technically is 13.4, so it looks like it actually is at 13.4, not 13.5. But in the question it says, which of the following best represents. So that's that indicates that it's it's not exact, but it's just which is closest enough to it. Next question, we have another line. And here we want to know, okay, the point, basically, there's a point on this line that has a y coordinate of 4. What is its corresponding x coordinate? So, basically, it's like this point right here. It wants to know what's the x coordinate of it. So there's multiple ways that you could do this. So you could, first of all, you could find the equation of the line. And then once you found the equation of the line, then you could plug set 4 equal to y and go ahead and solve for x. But I'm just going to save some of the work. So I'm going to do that, but I will save some of the work just to do it in Desmos because it's going to be quicker. So notice we have 2 points on this line. We can pick its y-intercept here, which is 0, 7. And then we can pick its x-intercept, which is just 8, 0. So now I'll do the exact same thing that I did on the last problem, basically a linear regression. Okay, so here's the equation of the line. Now, from this point, there's two ways you could do this. The longer way would be to technically take the equation of the line, y equals mx plus b, plug in the m value, negative 0.875, plug in the b value. For x, that's technically like d, the variable we're trying to find. And for y, you would just plug in 4. So you would get negative 3 equals negative 0.875d. And then divide by that. So go back to Desmos. Negative 3 divided by negative 0.875. Okay, we get this value, but can we turn this into a fraction? Yes, we can. So you can see correct answer is 24/7. So it's going to be letter C. Now I will show you the much quicker, and so right here, letter C, 24/7. The much quicker and easier way to do this, where you do the entire problem in Desmos, is the following. Do the linear regression, we get the equation of the line. Then we're trying to find the x-coordinate that has a y value of 4. So I'm going to graph the line y equals 4. Then I'm going to see where they intersect. Okay, where do they intersect? Well, 3.429. So the problem is if you just type in 3.429, it's not going to I don't think. Yeah, see, it's not going to give you the 24/7 that you want. So what you would have to do now is you would have to look at the answer choices and see which one is basically equivalent to 3.429. So, okay, obviously 7 halves is 3.5. That's not it. 26 over 7 is 3.714. That's not it. 24 over 7. 3.4285. If you rounded that, it would be 3.429. So that looks like it's the answer. And then just to check 27 over 8, 3 points, that's obviously wrong. So you would get the answer the same way. You just would have to double check these fractions to see which is equivalent to the decimal you get at the intersection point. But that's how you can do pretty much the entire problem in Desmos. Next up, we have a table and we have a quadratic function, and they want to know which equation defines this. So there's a couple different ways you could do this. Technically, I mean, you could take these 3 points and you could set up 3 equations with 3 unknowns, but that's way too much work. That takes up way too much time. So you can also do this entire problem in Desmos. So I'll show it that way first, and then I'll show the another actual way you could calculate it out as well. So all you have to do in Desmos is just make a table with the 3 points, and then we do a quadratic regression. And we get A, B, and C. Okay, A is 1, B is 5, C is 14. So we're looking for 1x squared plus 5x plus 14. All right, it looks like it is letter D down here. So that's going to be the correct answer. Now, how could you do this if you didn't want to do it in Desmos or didn't know how to do it in Desmos? So the easiest way is to just pick one of these points, plug in the value, and see which thing corresponds to it. Now, the problem is if you plug in 0, they all equal 14. So that one doesn't really help you. If you plug in 1, a lot of them, there are multiple ones that equal 20. D is going to equal 20. You can see B is going to equal 20 as well, and A is going to equal 20. So that doesn't help you. You technically would have to use this point right here to differentiate between the answer choices. So, for example, if you plug it into D, negative 1 squared plus 5 times negative 1 plus 14. 1 minus 5 plus 14. Negative 4 plus 14, and you get 10. And again, this calculation, you could obviously do this in Desmos. You don't have to write this out by hand, but just this process of plugging a point in to see which function it matches is an alternate way to solve this. So again, correct answer is going to be letter D. If you plug negative 1 into the other equations, the other functions, they will not come out to positive 10 as the y value. Next, number 6, we have a function. It technically is a linear function, even though it might not look like it. And it wants to know, okay, there's some value of a that when you plug it in, it equals 10. What is the answer? So two ways you could do this. We actually already solved problems very similar to this. You can just set it equal to 10 and solve for x. Multiply both sides by 5. And then subtract 15. X is going to equal 35. Letter C, correct answer. Alternate ways to do this. You could go through the answer choices and you could back solve this, meaning take the value, plug it in for x, add 15, divide by 5, see if it equals 10. 5 plus 15 is 20, 20 divided by 5 is 4, that's not 10, and you move on. Third way you could do this is exactly what I showed on an earlier question in Desmos. We can go ahead, you can type f of x, but I'm just going to type it as y. I don't want that. There we go. Okay, so here's the graph of f of x, which is just a line. Now, I will graph the y equals 10 thing, and I will see where do they intersect. And you're going to have to scroll a bit, but right here, 35, 10. So the correct answer for the a value that gives 10 as your output is 35. Letter C. That's how you can solve it, again, in Desmos. All right, next up, number 7, we have some parallel lines, geometry problem here. So they tell us that x right here is 6x plus 13. They tell us that y is 8k minus 29. And they want to know what the value of z, sorry, this is k. This is 6k minus plus 13, not 6x. What's the value of z? So basically what you have to know for this is that x and y, since they are vertical angles, will be congruent. So therefore, 6k plus 13 equals 8k minus 29. You go ahead and solve this. You get 2k equal to 42, or k equals 21. So now when you plug that in, that means that this entire angle where the y is going to equal, let's see, 8 times 21 minus 29. So if we go and work that out, it's going to be 139 degrees, basically 168 minus 29. And then z and y are same side interior angles. They are supplementary. So basically z plus 139 is equal to 180. So you just subtract 180 minus 139. And that is going to give you 41. So z is going to be 41 degrees. And there's no more work to do on this problem. Okay, next question, number 8. Here we have another line, and we have a line which is perpendicular to it. We want to know the slope of this perpendicular line. So this line right here, you can just find its slope by putting it into slope-intercept form. Just subtract the x term over to the right, divide by 2. You get y equals negative 9x plus 9 halves. So the slope of line P will be negative 9. Line R is perpendicular to it. So the slope of the perpendicular line is going to be the opposite reciprocal. So that means we flip the 9 or the negative 9 to the bottom, and then we also take the opposite of it. So it will now turn positive. So the slope of the perpendicular line will be positive 1/9. Correct answer for this one is letter C. Nothing more that you need to do for that problem. Number 9, they have a question here that deals with density. So they notice they don't give you the actual formula. However, they tell you the density is kilograms per cubic meter. So in other words, you're taking a mass, that's what kilograms are, and dividing it by a volume. Okay, that's what cubic meters represent. So the sample in this shape is a cube, and each edge is 0.9. Okay, so it's like whatever you draw out the picture, blah 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 here. Okay, 0.9, 0.9, 0.9. So what is the mass? So basically, we know the density, 807. We don't know the mass, but we don't know the volume, but we can calculate it. It's just going to be 0.9 cubed, or 0.9 to the third power, essentially. 0.9 times 0.9 times 0.9. So you just do that, and then you multiply, by that on both sides, and the mass is going to turn out to be 588.303. That you can just do in Desmos. Again, here you multiply by 0.9 cubed, or you can just get the decimal equivalent and multiply by that on both sides. So the correct answer is just going to be A. To the nearest whole number, well, it just rounds to 588. So that's it. Nothing more to do on this problem. Next, we have an exponential function. And so in this problem, okay, this is telling you how much the population is going to increase, like after t years. Well, specifically, so 2 years after 2005. Okay. According to the model, it's predicted to increase by n% every 18 months. What is the value of n? All right, there are two different ways you could do this one. So the first way is to notice, okay, 18 months is the same as 1.5 years, okay? Because you just take 18 divided by 12, 12 months in a year, and so 18 months is equivalent to 1.5 years. So now the question is, if you plug in 1.5 for t, what does the overall percent increase become? So notice what happens here is you take the 4/6 and now you multiply that by 1.5. Those technically cancel out and just equal 1 because 1.5 as a fraction is just 3 halves. So it's like 4/6 times 3 halves, you get 12 over 12, which just reduces to 1. So you ultimately get 290, the initial amount, times 1.04 to the first. Well, 1.04 to the first is just 1.04. So this is the same as a 4% increase. In other words, when you multiply a number times 1 point x, that x, whatever that decimal value is, that is your percent increase. So the correct answer for this one is letter C. Now, let's say you didn't know that, you didn't follow that, didn't see exactly how to do that. Okay? So here's how you could also do it using Desmos and the technique of picking numbers. So basically what we're saying is, how much does it increase every 18 months? So first thing I'm going to do is I'm going to do t equals 0, meaning at the start, and then I will calculate what the percentage is first, and do that, and then I'll calculate the percentage after 18 months, i.e. I'm going after 1.5 years, and then I will see how much did it increase. So the first thing, so up here we've got 4/6 times, here we go, times, and I'm just going to put it in the numerator because that's fine. And I'm going to plug in 0. So notice at the beginning, the initial population 290, right? Okay, now I'm going to do it where I'm taking the 4/6 and I'm multiplying it by the 1.5 years, because remember, t is in years. You don't plug in 18, you plug in the number of years that 18 months is equivalent to. Okay, so my new population after 18 months is 301.6. To find the percentage change or percentage increase, you take the new minus the old and divide it by the old, or by the original. So 301.6 minus 290 divided by 290. It went up by 0.04. which is the same as 4%. So this just confirms the correct answer is going to be C. So this is picking numbers. This is, an alternate strategy you could use to solve this one. Next up, we have question number 11. Here we have an equation. It's got some constants in it. Um, we know that the n is greater than 1. We don't know anything about k. We know the equation has no solution. What is the value of k have to be? So the thing is, technically, you can do this one in Desmos. I'll just show you it briefly at the end, but it's very difficult to do because the answer for this is not a nice integer. It is a decimal, especially if it's a repeating decimal. So you have to keep zooming in, zooming in, zooming in to make sure you have enough decimal places to get it correct. So first, I'll show how you can do it by hand. I'll distribute the 2 that's in front of the left side, and then on the right side, just copy it down. Okay. So for this to have no solution, this linear equation, what has to happen is all the x's have to cancel out, and then you're left with 2 different numbers. All right. So all we're concerned about is the 2 x terms. Specifically, they have to be equal to each other. So if I take the coefficients in front of them, the 2k and the negative 28 over 15, and I set them equal to each other and solve for k, this will be my answer. So I divide by 2, divide this by 2. It's going to turn into negative 28 over 30. That reduces to negative 14 over 15. So you could put that as your answer, negative 14 divided by negative 15. You could also write the decimal equivalent, which is negative 0.9333. Okay, so that's the correct answer. But what I want to show you is the reason why this would take some significant period of time in Desmos. So I would graph the left side. I would add sliders for all for right now. I'll come back to them in a second. I would graph the right side. Okay, now n has to be greater than 1, so just set the slider for n equal to 2. Okay, it doesn't, whatever, it doesn't really matter. All right, here are my 2 lines. For no solution, I need these 2 lines to be completely parallel. So now I'm going to change my values of k, okay? So notice when I increase them, even if I like jump this up to 50, they're not getting parallel. It's just getting really steep, but it doesn't flip the other direction so it's parallel. So let's try going negative. Okay, notice there, notice there it's like, yeah, it's pretty close, pretty close. So like now I at least know somewhere, where to zoom in on. So like I got to check between, let's set the upper limit at like negative 0.5 and let's set it at negative 1 and let's set the step at 0.001. Okay. So now, see, it's really difficult to tell exactly quite when they're parallel. I mean, you have to zoom out and see, like, do they intersect? Do they not intersect? Here, they technically do intersect. And that's why if you zoom in even further here, so like we know it's pretty close to this. So if you go to 0.93 0 as the upper limit, and let's say like negative 0.935 as the lower limit, and I'll set the step, even smaller, okay? Oh, I typed in the positive one by mistake. I want this to be negative. There we go. See, it's really hard visually to distinguish like when exactly they're parallel. It basically will be like right here. This is technically the 2 lines being exactly parallel, and they will never intersect, and therefore there'll be no solution. But again, visually, it's tough to do this. So that's why I would not solve this one using Desmos. I mean, you could take your answer you get, and you could plug it in and see if your answer makes sense. But just to solve it, I would do this one by hand instead. All right, next question. Here we have a problem with percentages and a gift shop and everything. So basically, you start off at $7, okay, and then it resells as 290% of that. So that's basically the same as multiplying by 2.90. So if you go ahead and do that, the sale price is going to be 2030. I guess we actually I'll call that that's the retail price. Then they discount it 80% off of this. So basically now you're doing, okay, 2030 minus zero point 0.8 times 2030. You're taking 80% of it and subtracting it. And if you do that, it just comes out to 4.06. So the correct answer, what's the discounted price? Well, it's just $4.06. So start with the original amount. You find 290% of that. And again, this we should be able to do in Desmos as well, just with the percentages. So 290. So first, 290% of 7. Okay, so that would give you the 2030. And then you need to know it's 80% off. So 80% of 2030. Okay, and then we just do 20.3 minus 16.24, 406. So obviously so much quicker and easier to do it, just the calculations and stuff in Desmos. Next, we have another problem that you can technically again do in Desmos, but it takes a while because the number will end up being so large. So here we have a quadratic function. You have some number. Okay, C here. This equation has no solutions if this C number right here is greater than some other number n. Okay, and they want to know what is the least possible value of n. Basically, how low can you make n such that this equation would still have uh, no real solutions. So, okay, the math way to do this is to do the discriminant, meaning the traditional way, b squared minus 4ac. For no real solutions, you want it basically less than 0. So if you plug in the numbers, negative 34 squared minus 4 times 1 times c, less than 0. Okay, we get 1156 minus 4c less than 0, negative 4c less than negative 1156. And then when you divide, it'll flip the sign. So c has to be greater than 289. So look up here, c greater than n. C has to be greater than 289. So what's the smallest possible value for n? Well, it's 289. And that's it. It's the correct answer. Now, here's how you could do it in Desmos. So we just graph this function. Add a slider. All right. And basically what we're looking for is um, no real solutions means we want no x-intercepts. In other words, this graph, because it opens up, will have to be completely above the x-axis. Okay, so if I go to 10, notice I still have intercepts. The thing is way down here, the 280s. Okay, so that's a clue that you have to shift this up, like a lot. So let's do 280, whatever, to 300. All right, it's still below, still below. We still have two real solutions. We want none. So like right around here is where you can see, let's hit the step value at 1 because we know it's an integer. Okay, now we can zoom in. All right. So when C is 289, it is exactly on the x-axis. There is one real solution and it is the number 17. Basically, it's a double root, okay? So that means for no real solutions, C has to be greater than 289. Basically, it's got to be, really it's 289.0000000, 1 or whatever. But the point is 289 is the lower limit which C has to be greater than. So you could get this doing Desmos as well. It's just you have to recognize that you have to shift the graph up a lot, i.e. your slider values have to be, very large to figure it out. Next question, it's another student-produced response. This one deals with some data sets, specifically with essentially what it is. It's really a frequency table. So you have one set that has 75 buildings, and the mean of those is 32. The other has a mean of 50, has 50 buildings, mean of 62. C is just all these buildings all together, and they want to know what the mean of that is. So this is basically just a weighted average. The whole idea is you take there's 75 buildings in the first, and their mean is 32. That means the sum of all the heights is going to be 75 times 32. It's 2400. We don't care what the individual values are. We just care what the sum is. Because basically to find the sum of data set C, we need to, or excuse me, to find the mean of data set C, we need to sum up all the buildings that are in it and then divide by the total number. So the total number is going to be obviously 125. The sum of all the buildings in A is just 75 times 32. The sum of all the buildings in B is just 50 times 62. That is equal to 3100. When you add those two together, you get 5,500. You divide that by 125 and you get 44. So the correct answer to this one is 44. Now, you could also technically do this one in Desmos. What you would do is you would create a table, and in the table, we will put the values first. Excuse me, we'll put the mean first. We want to put the mean first and the number of buildings second. So technically the value is first and the number, the frequency is second. And then we want to do the same thing for data set B. We want the mean first and we want the number of buildings or the frequency second. And then what we type in as follows. We want to take the total of x1 times y1. That basically goes across each row and it multiplies like the x1 and the y1 value. And then we divide that by the total number of buildings, which is just the total for column y1. So this is basically the formula you can use to get the average or the mean from any data that's entered in a table, essentially basically a frequency table like we have here. So this is just an alternate way to type it in. It's doing the same exact calculations that I did previously. Next up, question 15. We basically have a quadratic function, except they don't give us one of the coefficients, just generic b. And then they're basically saying, okay, if you factor this function, which of these following expressions must be an integer? So, easiest approach I think to take with this is just picking numbers. So, for example, I'm just going to factor 4x squared plus bx minus 45 as the following. Okay, notice that since the second parenthesis has just a 1x, that means that the first parenthesis would have to be 4x. And now for k and j, those are just going to be two factors of negative 45. So I just chose to go with plus 9 minus 5. So this means when you FOIL this out, and I'm really only concerned about the inner and the outer terms, the outer term is negative 20x, the inner term is plus 9x. So I got negative 11x. So now as we go through, I'm just going to identify, okay, h, which is the number in front here, is just positive 4. J, which is the number back here, is negative 5. K, which is the number here, is positive 9, and B is just negative 11. That's the number I got in front of my X term when I multiplied it out. So now I just run through these. B over H, negative 11 over 4. Is that an integer? Nope, can't be the correct answer. B over K, negative 11 over 9. Is that an integer? Nope. All right, next, C, 45 over H. 45 over 4. Is that an integer? No. So by process of elimination, we can see it has to be D. Now, here's the mathematical reason or the theory behind why D is the only one that's correct. So notice that when you factor, right, these two numbers here are automatically factors of the constant term, or in other words, the number term at the end, the C value, just because that's the way FOIL works. So 45, or technically negative 45, but we can ignore the sign of it. The 45 here, both k and j have to be factors of that, which means when you divide it by k or by j, you're going to get an integer value. That's what it means for something to be a factor of it. All the others are not necessarily, factors of each other. So that's the kind of mathematical theoretical explanation for why D is the correct answer. Next question, we have another student-produced response. So this one, again, is another one where you can do it in Desmos, but because the answer is not an integer, it's a decimal, it might take you a little bit of time to figure it out. So I will first show kind of the theoretical explanation for it, and then from there go on to show you how to get the how you could do it in Desmos. So if these are intersecting at only one point, okay, um, because it says it has exactly one distinct real solution. So basically, what's happening here? Um, these two things are going to intersect, but they're only going to intersect once. So if you visualize it, it's like you have a parabola here, and then you have this horizontal line, y equals negative 1.5, and basically there's just one point of intersection. That point of intersection happens right at essentially the vertex. So there's multiple ways you could think about this, or you could do this. So normally, system of equations, right? We set the two things equal to each other, so just replace this y with negative 1.5. Okay, and then if you move that over, you get x squared plus 8x plus, and then it's a plus 1.5 for your number term here at the end. So essentially now what's happening, if you think about this, since it's now equal to 0, really what's happening is we want the discriminant to be equal to 0 because that's how you get one real solution or 1, 0. So if you think about this, b squared minus 4ac, okay, you get 8 squared. We want to set that equal to 0. 8 squared minus 4 times 1 times the a plus 1.5. And we just go ahead and solve this equation out. 64 minus, now this you're going to end up distributing. So first of all, this is just going to be 4. So it's going to be minus 4a, and then it's going to be negative 4 times 1.5, which would be negative 6. You get 58 minus 4a equals 0. Negative 4a equals negative 58, divided by negative 4, and it's just going to reduce to a equals 29 over 2. You could also grid it in as 14.5 as well. So that's the correct answer right there. This is basically the math traditional way to solve it. Now, so if you want to go, just to show you, go do this in Desmos. So I bring up Desmos, right? I'm just going to plot both things, and I'm going to put in a slider for A. All right, so now, first of all, you can see it's clearly way below it now. So I move it up to 10. All right, I need to jump it, even more. So let's keep going. Okay, so it looks like, so notice right here, I happen to get 14.6, and it's like so close. It's not quite touching it once, it's still above it. So it's got to be less than that. But notice 14.4 is below it. So now what I would do is I would go 14.4 to 14.6. I know it's between those, and do a step value of like 0.0, maybe 0.001. And now you can see, as you side note, it's getting closer, 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 closer. Again, you might have to zoom in here. Oh, look, 0.523 is too high. So keep going down, keep going down, keep going down. And this is how you can tell that right here that there's just one intersection because it highlights, there's the gray dot when you click on it. Whereas if I was technically down here, notice when I try to click on it, there's 3 points, okay? So that is not one intersection point, or sorry, there's 3 points highlighted, meaning there's 2 intersection points and the vertex as well. So that's what tells you it's too low. Whereas if you're up here, see, there's an intersection point, but you have to like really zoom in just to confirm, yeah, it's not actually touching it once, it's really above it. So it's kind of a pain to do this in Desmos, but you can still do it and get the correct answer as well. All right, next question. We have a data set given basically in a dot plot here. And in this one, we're then told that you make a new data set by adding 56 to each value. So like data set B is essentially going to have, for its values across the bottom here, let's see, 78, 79, 80, 81, 82, and then it would have the same, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. And they're asking us to compare the median and the range of each of these. So the ranges are going to be equal because the range is just the difference between the highest and lowest value. That's 4 for the first one, 26 minus 22, and that's still 4 for the second one, 82 minus 78. So the range of B is equal to the range of A. So that means we can keep this one, we can eliminate this, we can keep this one, we can eliminate this right off the bat. Now, when comparing the medians, i.e. the middle number, okay, obviously, if you have values between 22 and 26, the median is going to be somewhere in between there. But now if you have values between 78 and 82, the median is going to be between those numbers. So which is bigger, a number between 78 to 82 or a number between 22 and 26? Okay, obviously the 78 to 82 is bigger. So the median of B will clearly be bigger than the median of A. So correct answer is just going to be C. I mean, you could also technically like go plug this into Desmos to confirm it, but hopefully you see that a bunch of numbers in the 70s and 80s will have a higher median than just a bunch of numbers in the mid 20s. Next up, number 18. Here we have a basically it's a graph of could be an exponential, could be, although it looks like based on the form they give us, it's actually a rational function. So there are multiple ways you could do this. One way is to, okay, so a couple different ways to think about this. First way is I would notice that this function, if you're familiar with rational functions, notice it looks like it has a vertical asymptote here at -4, which means that in the denominator you have an x plus 4, because remember your vertical asymptotes come from setting the denominator equal to 0. And if you go ahead and do that, if you go and set it up like this, okay, g of x is just f of x plus 4. So that means you take x and you replace it with x plus 4. So if you do that, you now get just whatever a is over x plus 8. Go through the answer choices. You only see one thing which has x plus 8 in it. Cross that out, cross that out. So it's got to be letter C, and that is the correct answer. So this is one way, basically, to think about it. An alternate way to think about it, just without even writing out the functions like that, is, okay, it looks like this function, again, has a vertical asymptote here at x equals -4. If g of x is going to be defined by this, that means that everything's going to be shifted to the left 4 units. An x plus 4 in the parentheses means shift everything over to the left 4 units. So this vertical asymptote would move over 4 units, and now it would be at x equals -8. So again, looking at the answer choices, which one of these is not defined or would have a vertical asymptote at -8? Well, it's got to be letter C. Okay. Finally, you could also technically go to Desmos and just fool around with it. And so what I mean by that is so we type in the original function, okay, f of x. So let's do a plus b. Let's do sliders initially for all. Now, and just zoom out. Okay. So whatever, we have a picture that looks like this. Now notice this is not the exact graph. So if we wanted the exact graph, technically we'd have to move b over here to 4 just to match it. But in reality, that actually doesn't matter. And I'll show you why. So now if we do g of x equals f of x plus 4. So basically, this just confirms, right, that it's shifting 4 units to the left. So guess you would actually need to know that it does need to be 4. Just what I would do now is I would go through the answer choices and I would graph. And I would see, okay, basically what I'm looking for is which of these answer choices matches the answer. And actually, I'm going to set a equal to 6. I should do that because that's what it is. That's what all the answer choices have in the problem. So what I'm looking for is the green, which is the g of x after, f of x after the shift. Which answer choices does it match or match up with identically? So here, add the plus. So now check answer choice B. It still doesn't match. Let's check C. Notice it matches perfectly, and that's the correct answer. And of course, if you matched A, if you put in D, okay, that doesn't match. So an alternate way would be to graph out the original function, then put in the answer choices, and then or put in the transformation, and then put in the answer choices and see which answer choice matches the graph of the transformation. All right, 19. This is another one that technically we can do in Desmos as well, but it's actually not that bad to do just by hand. So look at this problem. It tells us the product of the solutions is equal to this KAB. So the product of the roots or the solutions for any quadratic function is just equal to C over A. That's a formula you should have memorized. So in this specific problem, that's going to equal C, which is AB, over A, which is 57. It tells us that's equal to KAB. Okay, so now notice, no, basically you can cancel out the ABs, or you could just divide both sides by them. And then what's going to happen on the left is AB over AB. You're just left with a 1. So what does K have to equal? 1 over 57, and that's it. So again, that's not long, that's not a lot of work. That's not long as long as you know the formula and how to set it up and everything. But here's how you could also technically get this in Desmos. I mean, this is a little more complicated, but still I want to show it just because, it is useful. So we go ahead, we graph out the function. All right, we're going to add a slider for both A and B. And I'm going to adjust the sliders. All right, whatever. I'm going to, actually, no, we'll do it this way. Let's see, is that, yep, that's direct line 2. Okay. So the product of the solutions is equal to K times A times B. So the two solutions I have are negative 0.175 and negative 2. Negative 2, negative 0.175. I multiply those together, I get 0.35, okay? So my product of the solutions is 0.35. That is equal to K times A times B. Well, what's A times B equal? Well, I said B is 2, A is 10. So that's just equal to K times 20. And now you could divide both sides by 20. So K equals whatever 0.35 over 20 is. 0.0175. Now, notice that doesn't give me anything that matches the answers exactly because this 0.175, negative 0.175, is rounded. I didn't like extend it out enough with enough decimal places. But we can still look at these answers and figure out like which one is that makes sense. What I mean by that is, okay, it's obviously not 57, it's obviously not 1. Is 1 over 19 equal to this number? No, it's 0.0526 whatever. So obviously B is wrong. So by process of elimination, it's A. And if you do A, notice it's pretty close. It just has more decimals. It's 0.0175, 438, blah, 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 blah. But still, we know that A has to be the correct answer. So that's how you could do this entire problem, again, in Desmos as well. Next up, we've got a circle question. This is also another one you can do in Desmos, but I will also show you how to do it by hand. So first, I will show just how to do it by hand, and that would be completing the square. So you go ahead and put the circle into standard form. And here it's just kind of annoying because the b value is 1, which means when you take b over 2, you get 1/2. So when you square it, it equals 1/4. So you're adding 1/4 and adding 1/4 for both the x and the y. So you get fractions. So on the right side, of course, we're going to add 1/4, add 1/4. So on the right side now, we've got 199 over 2 plus 1/4 plus 1/4. Well, 1/4 plus 1/4 is just 1/2. It's really 2 over 4, but I just simplified it to 1/2. 199 plus 1 is 200. halves or 200 over 2? Okay, so in standard form, this circle equation will be equal to 100, and that is the value of r squared. That means r is equal to the square root of that, so the square root of 100 is just 10. Okay, so correct answer for this question is the number 10. But you could get this in Desmos, okay? Here is how. So let me clear out all this stuff from the last problem. Type the circle in solely as it's provided equation. Don't need to do anything. Okay, here is the graph of it. Zoom out. Here is where you need to be careful. When you click on the circle, notice there are 2 points highlighted here. One is a y-intercept. You do not want that. The other is the endpoint of a diameter. That is the point you want. Do not use the y-intercept. A lot of students use the y-intercept values and they like find the distance between those and divide it by 2. That's not the radius. That's because that's the circle technically is centered, if you do it out, at negative 1/2, negative 1/2. It's centered like right here. It's not centered at the origin. So what you want is this point and this point, okay? So what's the distance from 9.5 to negative 10.5? So I just subtract them. The total distance from top to bottom of the circle is going to be 20. That is the diameter. Half of the diameter is the radius. Therefore, the radius is 10. That's how you could figure out this entire problem in Desmos, without needing to do any of this work. Next up, 21. One of the most difficult questions, probably the most difficult question on this test. So basically, you have 2 prisms here that are stacked on top of each other. And you can use Desmos for part of this to figure it out. So, okay, so here's the first one. All right. And then what you have, and these also, a couple things. So the height is 90. They tell us the surface area is k squared, whatever. We'll get to that in a second. The base is a square. So like whatever, this is x, this is x. We don't know the value, but we know they're the same. Okay, and now on top of this, we have another prism. Okay, with the same height of 90. They want to know the side length of the base. Okay, and the 2 pieces of information they give us is the surface area for each prism. So the surface area for one is just this capital K. And if they're glued together, the total surface area, so this is surface area of one, surface area of the total picture is 92 over 47K. All right, so here's what we have to do. First, the surface area for one prism is going to be the total area of all 6 faces. Okay, notice there's a top, so I'm just going to work with this first. The top and the bottom have a surface area of x squared, okay? And since there's top and bottom, it's going to be 2x squared total. Then there's like front, back, and left, right. Those each have a surface area of 90x, but there's 4 sides because there's front, back, left, right, okay? So the total surface area for one prism alone is 2x squared plus 4 times 90x, or 2x squared plus 360x. So you could set that equal to k. Now, let's look at the total configuration together. Basically here, you're going to have a total of 8 of the 90x sides. You're going to have like 2 fronts, 2 backs, 2 rights, 2 lefts. Okay, so there's 8 sides that have an area of 90x. And then there's only 1 top and 1 bottom. So again, it's 2 times x squared, because the inner, like the bottom from the top prism and the top from the bottom prism, those are covered up. Those are not counted in this 92 over 47 k value. So now what we can do is we can go ahead and basically solve because we have two equations with two unknowns. Okay, we have x's and we have k's. So what you do is you take this expression, you substitute it in for k over here, and then we can go ahead and simplify and solve it out. And we'll actually just use Desmos to solve it. So, for example, we get 720x, I'm just distributing, okay, plus 2x squared equals 92 over 47. And now for k, it is 2x squared plus 360x. Okay, so all I did is I replaced k with what it's equal to from the surface area of one prism. So this equation now, this is kind of a pain to solve. I mean, you could like distribute the 92 over 47, and then you could get rid of the fraction, blah, blah. But we don't need to do any of that. We can just go to Desmos and get the answers, straight from Desmos, and then that will allow us to figure out the side length. Basically, that's what x is. So how can we do that? You could type the whole thing in, but what I actually like to do is I type the y equals the left side, and then I type y equals the right side. I see where they're equal to each other, where they intersect, and then those are going to be the two answers. All right, so let's see what's going on here. Y equals 720x plus 2x squared. It's a quadratic. And I have y equals 92 over 47 times 2x squared plus 360x. So these, let me see here, 92 over 47 times 2x squared plus 360x. Okay, so the problem is the intersection points have extremely large numbers. Okay, and it looks like they're off the screen. Yeah, they're going to be way up here. So actually, never mind, change that. We'll do it this way and get the answer. Sorry, just this is where it's actually useful to type in the whole thing. Get rid of this. Okay. All right. Sorry. So this is where it's actually useful to type in the whole equation rather than setting the sides equal. So now I can clearly see that when you solve this equation, you get two answers. You get x equals 0 or x equals 8. So what is the side length of each square base? It's just 8, letter B. Obviously, it's not 0 because then everything would be 0. But correct answer is just going to be x equals 8. And you can solve, once you go through the the fairly complex process of setting up the equation and everything, then the actual solving of it, you can just do, in Desmos. All right, next, let's talk about this last question, number 22. So with this one, unfortunately, as of right now, there's no way I know how to solve this entire thing in Desmos. Basically, what you have to do is you have to start with the equation in vertex form. So just put the vertex in. Then we go ahead and basically square this out. Then you distribute the A. And now what happens is, like, this obviously A matches up with that A. Okay. This and just this actually, sorry, matches up with B, and then these two terms together correspond to C. So if you add A plus B plus C all together, okay, meaning just taking the coefficients, you get A minus 18A plus 81A minus 14. So this is again A plus B plus C, just all together, the coefficients. And now when this is 81. Now when you combine these, you get 64A minus 14. So the way we determine which of the following could be equal to this is basically we need A to be positive. So essentially what you're looking at is like, okay, let's say these equaled negative 23, which is answer choice A. Okay, would A be positive? Well, I'm not going to do it by hand. I'm just going to like go ahead and essentially I'm just going to put an x for a. So here's my equation, okay? I'm just going to type the whole thing. Okay. Is my solution to this positive? No, it's a negative value. It's negative 1.41. So that one cannot work. The reason A has to be positive is because in the problem, it tells us the vertex is at 9, negative 14. So that's like over 9, whatever, down here. And it intersects the x-axis at 2 points. So it has to open up in order to do that. Okay, so now going back to here, let's try negative 19. Is A positive? Nope, still negative. Let's try negative 14. Notice this one is exactly 0, okay? A is not positive. It's not negative, but it's 0. So therefore, it's still not positive. So it's going to be D because notice here, now when you solve this for A, you get a positive value, and that matches the information given in the problem. So the correct answer for this one has to be letter D. Now, here's an alternate method you can actually use to solve this problem entirely in Desmos. Now, this part of the video I recorded after I recorded the initial solution to number 22, doing it by hand. And so I actually discovered that you could do this problem entirely in Desmos, after the fact. So I'm just adding this in afterwards. So here is what we can do. So first, bring up the Desmos calculator. Okay. So I'm going to add a table, and I'm going to add the points 9. I'm going to add 9, negative 14. That's my vertex. And I'm going to add 2 more points. One is just going to be 9 plus d comma 0. That is one of the x-intercepts. The other one's going to be 9 minus d comma 0. So basically, if you think about it, you have the vertex at 9, negative 14. Then you have your 2 intercepts, which are symmetric, meaning one is to the right by some distance from 9 and the other's to the left by some distance. But I know that their y values are both 0 because it says in the problem it intersects the x-axis at 2 points. All right, so now I'm going to do a linear regression. Now, notice so far nothing's happened. I don't have a graph. So what I have to do though is I'm basically going to add a slider for the d value. So let's just say d is equal to 1. Okay, so now I've got a graph. Now I've got values for a, b, and c. And notice here it says, which of the following could be the value for a, b, and c? So what is a plus b plus c equal? All right, it's some gigantic number, all right? What about if I go, if I go negative, well, the numbers get smaller. What about if I go positive? Notice as I increase it, the numbers are starting to get smaller and much closer. As it gets wider, the numbers are getting closer to these values in the answer. So I go up to 10. All right, it's at negative, but it's not quite at, anything that's in the problem. So let's just, whatever, jump it up to 50. Okay, so notice we're starting to get close to negative 12. Now, we can't, it looks like here I'm over negative 12, but if I go back here, I'm under it. So it looks like when my d value, i.e. the distance that the intercepts are to the right and to the left, is between like 21 and what, 21.3? Yeah, between 21 and 21.3, it looks like it will hit negative 12 somewhere. So that's basically confirmation that D is the correct answer. But here's how you know that for sure. Let me just zoom out here so we get a better picture of the graph. Notice as I continue to increase, okay, even up to 50, let's just jump it up to 500, and I'll set the step value just at 5. Okay. Notice as I'm scrolling, it's negative 13.9, and it's getting really, really, really close, negative 13.995. It's getting really close to negative 14, but it never actually hits it. Even if you scroll to like 10,000, and I'm just going to set the step value to 100. Whoops, there we go. Okay. Notice it's getting negative 13.9999999, and it's getting real close to 14, negative 14, but it never actually hits it. So this is confirmation that a plus b plus c could be negative 12, and it cannot be any other values. Again, this is how you could solve the entire problem in Desmos, really without any work. Again, just to quickly review, what I did is I made a table. I entered in the vertex point. I entered in the 2x intercept points by doing 1 plus some slider value for d, 1 minus that slider value for d off of the x coordinate, the h value of the vertex, did a quadratic regression, and then I moved my slider values for D to see basically what the values of A plus B plus C would be, would be equal to. And I saw that it goes across a negative 12, but it does not touch or equal any of the other numbers. Okay, so this is just an alternate solution to number 22. This last question on practice test 4, module 2B. And now it'll, basically resume with the rest of the conclusion of the video. Okay, so fairly complex problem to work out, just like the one before it. But this is the last question on module 2B of practice test 4, the math section, obviously, from the Bluebook app. If you have any questions, comments about this specific module, please do leave them below. Otherwise, look out for the other videos on this practice test 4, the video on module 1 or the video on the easier second module 2A. And lastly, if you like this video, please do give it a thumbs up and subscribe to my channel and sign up for notifications as well.